So hi everybody, welcome back to the channel. So in this video we are going to discuss problem of the day of GFG, and this is the day one of our video. So the problem of the day of GFG is minimum days, and it is a easy medium problem. And what is given in this problem is you are given a string of length and containing only lowercase alphabets. Means in the string you are given lower alphabets, and you are also given a permutation p of length n. I hope you all know what is permutations, and if you don't know, then permutation is simply a permutation of length n. Means that the integers from 1 to n are present in the permutation, but in this permutation the integers from 0 to n minus 1. So the definition here of permutation is 0 to n minus 1 elements are present uniquely. And what we are given, what we have to do in this problem is, in I plus 1th day you can take the value of p of I of the permutation array and replace s of p of I with a question mark. So in our operation, what we can do in our first day, let's consider for an example, in the first day we can, what we can do, we can take the value of p of 0, and what is present in the string at p of 0, p of 0th index, we can replace that with question mark. And when we have to replace this with question mark, it is given here. You have to tell minimum number of days required such that after it for all indexes 0 to n minus 1, if s of I equal not equal to question mark, then s of I not equal to s of I plus 1. Means two adjacent alphabets should not be equal, like it is given here. A should not be equal, and if they are equal we can make anyone equal to question mark after following the rules of permutations that is given here. So let's take this example. In day 1 we can replace s of p of 0 with question mark, and what is given at s of p of 0, at p of 0 we are given 2. So in this problem we are given 0 based indexing at 2, what is present at position 2, b is present, so this is position 2. Okay, so b is equal to its next element, we can replace it with question mark. So after replacing, the string will be this. As we can see, s still has character a at index 0 and 1, so they are equal and both are adjacent. So in day 1 we can replace s of p of 1 with question mark. After that, string s will be this, and we can say, yeah, this string satisfy the conditions, none of the adjacent elements are equal. So this is the problem, and let's take another example. Here the value of n is 4 and string is a b c a, and you can see none of the adjacent elements are equal, so we don't need to apply any operations, we simply print 0. So let's see the logic of this problem. So let us consider a test case. So let us consider this is our string, and it is of size 8. So let the permutation is this, let the given permutation is this one, uh, 0 4 7 5 3 1 2, and you can see 3 3 6 7 8 1 2 3 4 5 6 7, what left, 1 2 3 4 5 6, yeah, 6 left. So you can see these adjacent elements are equal, these are equal. So what we have, first of all what we do, we will count those elements which are equal. So here the value of count is 2. We can say there are two pairs which are equal. If there is another one here, if there is another one here, then the count will be 3. Why? Because these two equal and these two equal. So but it is not present in this test case, so remove it. So what we have to do, uh, let's see here. On the day on the day one, on the first day, what we can do, we can do p of 0. What is p of 0? The value of p of 0 is 0. So we can replace p of 0 with question mark. What is present at 0 index? It is present a. And yeah, we can say a is equal to its next adjacent element. So the string will be this, look be like this, and remaining will be left same. And on the day second, what we can do operation, uh, on the day second we can replace at fourth, what the value of string is present at fourth index. 1 2 3 4, the value of at fourth index is this. So the what the string will be looks like, a b c question mark, and remaining will be same. So it's a easy test case. Let's see another test case. Let us consider our string is this. So the length of string is 7 and our given permutation is this. On the day 0 we can apply operation on 6th index of string. On the day second we can apply 4th index, then 5th index, then 1st index, then 3rd index, then 2nd index. So what we do, first of all we will count the adjacent elements, how much adjacent elements are present in the string. There we can see there are 3 adjacent elements. So the value of count is 3. So as in the given statement, if we apply operations on the day 1, we can apply PO, we can uh, change the value of string at P of at the index of which is P of 0. What is present at P of 0? P of 0 is 6. So first of all, let's draw the index. It is 3rd, it is 4th, it is 5th, it is 6th. So we can change it with question mark. So apply this operation, the string will be looks like this. On the day second, what we can do, we can change the value of p of 1. We can change the string at index p of 1. What is p of 1? As you can see, p of 1 is 4. So what is 4? 4 is this one. We can change it with question mark. So our updated string will be look like this. And on the day third, what we can do, uh, we can change the value of 5 at string at position 5. So p of 2 will be 5. So the our updated string will be this. Okay. Similarly, at day 4, we can change p of 3. What is p of 3? P of 3 is 1. So what is at index 1? This is a. So here we can see the value of a is equal to the here. So we can make here question mark, and our updated string will be this: a question mark a, b question mark question mark. And you can see now none of the adjacent elements are equal. So how we will tackle the adjacent elements? We will apply operation simply. At the time of applying this operation, we will check if s of p of I minus 1 equal to s of p of I, or s of p of I plus 1 equal to s of p of I. What it means, if let's say we are applying operation here, let assume here was 1, yeah. If we are applying operation at first index, and we will check if this a is equal to its last adjacent element, then we will decrease our count minus minus. First of all, the count of value was 3, and we will check this a will its next adjacent element, and if this is equal, we can apply count minus minus operation again. So that's all in this problem, and we will return when the count value of count will be 0. Obviously the value of count will be 0 of in the worst case when all the operations will be applied. When the count is 0, we will return there. At that time, what we will return on which day we don't have to apply more operations. That is, we will return the value of days through which we apply operations. So now see the code of this problem. So I have taken a variable position and count. What we will do with count, we will count the number of elements which are equal to their adjacent elements. So as you can see, if s of I equal to s of I plus 1, we will increase our count plus 1. And if we will check, it is the corner case if the value of count is 0, which means in this video, in this example too, the value of count will be 0. It means none of the adjacent elements are equal, so we'll simply return there 0. That is, we don't need to apply any operations, and we will simply start from 0 to v dot size in the permutation, and we will take v of I equal to position, and we will check if position minus 1 it is greater than equal to 0, because if it is less than 0, then it will give us runtime error. And we will check if s of position minus 1 equal to s of position. What this means? It means this, uh, we will simply checking if, let's say, the value of position is 1, so we are checking this a will with this one, uh, s of position minus 1 equal to s of position, we are checking this one. And if this condition true and s of position plus 1 is less than, and that is, here we are also checking if there could be runtime error, which means the position of the value of position could be n minus 1, and if position plus 1 equal to n, then s of position will give us runtime error. So we are checking this here, and we are checking if s of position plus 1 equal to s of position, which means if this a is equal to this, so the first position minus 1 is checking with the previous adjacent, and position plus 1 is checking with next adjacent. And if these both conditions are true, then we will decrease our count by 2. Why 2? Because we can apply operation at this position and make this a question mark, and by making this question mark, none of the both had when before applying operation, both of these adjacent elements are equal to a, and now after this, nor this a will be equal to question mark, and nor this a equal to question mark. So the value of our count will be decreased by 2, and we will simply make s of post equal to question mark. If this is condition is not true, we will check for previous adjacent. If previous adjacent, let's say if it was b, so if this condition will not satisfy because a not equal to b, but previous elements are equal, so if this condition apply, we will decrease our count by 1 only, and we will make s of post equal to question mark. And if this is not true, we will check if s of post plus 1 equal to less than n, and we will check the next adjacent element. If both are equal, then simply we will decrease our count by minus 1 and make the value at this value place question mark. And after that, if count is equal to 0, then we will simply return I plus 1. Why we are returning I plus 1? Because it is a 0 based indexing and days are 1 day. Okay, so I hope you understand the solution, and if you have any comment, If you have any doubt, then please feel free to ask in the doubt section. So thank you guys. Bye bye. Take care.